Good afternoon, everyone. Now, I know you're all incredibly excited to be listening to lecture after lecture from our incredibly scholarly pillars, who've definitely used no more than 5 sources exact. Now, with that aside, let us fill you in with our vast wealth of knowledge on the Brachiopoda, a species they step over on the daily.
Brachiopods are filter-feeding marine worm living inside a pair of shells. They're often called lamp shells due to their resemblance to early Roman oil lamps. They're lophophores, meaning they have a unique horseshoe or U-shaped structure, and they're marine animals that look like clams but are very different. They have very different anatomy and are also not closely related to mollusks. They're incredibly original, so much so that they are bilaterally symmetrical, utilizing big word developments such as organophosphatic or organocarbonate-based shells.
If you were wondering when the Brachiopoda decided to exist, these critters popped up around the early Cambrian period, around 450 to 550 million years ago, for all of us that in the room who don't know how time is categorized. These guys were so successful that 5% of them survived to date. A 95% extinction rate is no deterrent to the Brachiopoda, except for the 95%. The 95% that had enough left us around 250 million years ago, leaving only the few around now to enjoy the pleasantries of the ocean floor.
Now, of the 450 surviving species of Brachiopoda, there are 2 major classes, the Articula and Inarticula. Now, the Articular Brachiopoda utilize a series of sockets and balls in order to interconnect the shells, sort of like a modern-day gear system. Meanwhile, the Inarticula decided that they would far rather work harder than smarter and decided to use a series of muscle tissues to hold everything in one piece. Now, you might be wondering, why don't I ever see a Brachiopoda? Well, let me answer that question for you. These fine organisms enjoy a more exciting home to call their own. They enjoy the polar regions of the Arctics and also the deep crevices of the ocean floor, neither of which are particularly hospitable to our own kind.
During the Paleozoic era, brachiopods were extremely abundant. This allowed them to diversify into many different morphologies and participate in the buildup of ancient reefs. About 250 million years ago, brachiopods were hit with mass extinction and have not been able to recover their numbers since.
As free-swimming larvae, Brachiopoda use their lophophores for locomotion. Once they leave the larval stage, they settle and attach themselves to rocks or sediment and no longer move. Brachiopoda are protozoans, meaning their mouth develops before their anus. At the beginning of their life, Brachiopoda spend 1 to 2 days in the larval stage, freely swimming and freeloading off of yolk. Then they will attach themselves to substrate using pedicles, then undergo metamorphosis, where the mantle lobes, which begin to secrete valves, come forward to cover the interior lobe, which becomes the body and the lophophore. Chilling on a rock, Brachiopoda can live for 3 to 30 years.
Now, as I walk away and you look at these superimposed phylogenetic trees above and behind me, yeah, no, that's not happening. You see, using a free video editing software that may or may not require mildly sketchy ways to remove the watermarking isn't exactly intuitive in terms of superimposing still images onto video. And even if that weren't the case, I wouldn't, because I still have to study for what was yesterday's midterm, and this is the night before. And also, moving past the fact that our group definitely didn't forget to discuss this information or record this audio in person, I'm most certainly not recording this audio alone in my dorm room. That is definitely not what is happening right now. Now, moving past all of this information, let's look at these trees. Now, the tree on the left is going to be that of our 16S tree, and the one on the right is going to be based off our data matrices. Now, looking at these two, the most closest relative is going to be the mollusca. Also, our most problem child. We'll go on to that later. Now, the key difference you might notice is going to be in the positioning of the Brachiopoda between the trees and how its positioning interacts in close proximity to those around it, altering everything. Now, this can be most easily explained away due to the fact that the information the trees are relying upon. The 16S tree is relying upon genotypic information, while the data matrices is reliant upon phenotypic information. And in terms of phenotypic information, mollusca and Brachiopoda really want to be the exact same thing. they have incredibly similar phenotypic traits, and thus on the phenotypic tree are incredibly closely entwined and are altering everything. So, in what I can only describe as first semester freshman undergraduate education vocabulary, our graphs were confused. You look at these superimposed phylogenetic trees above and behind me. I would like to congratulate you yet again for making it through a video that truly reminds you how long 5 minutes can be in your life. Now, enjoy the rest of your afternoon.